It's time for a little concept review. So we're going to look at the idea of curve sketching through a simple example. So we're going to take the familiar curve sine x, so that's our original function, and we're going to take the derivative, cosine x, and the second derivative, negative sine x. And we're going to see what the first and second derivative really say about the original function. Now we could analyze this all throughout the real axis, but let's just concentrate on one particular part of the real axis. So we'll just look at the interval from 0 to 2 pi. And first we're going to concentrate on the derivative, f prime. So in blue, we've got the values of the function f, and then the purple graph is the derivative. So we'll notice that when f prime is positive, in other words, the values of the derivative function, when those values are positive, the original function is increasing, which you can see in this example. The values of the original function are getting greater as you move left to right. And where the values of the derivative are negative, that's where the original function is decreasing, which again you can see in this simple example. So the punchline here is the sign of the derivative tells you about the monotonicity of the original function. Look at the sign of the values of the derivative, and that'll tell you whether the original function is increasing or decreasing. So now we're going to concentrate on the second derivative. So here we have the second derivative plotted against the first. And we'll notice that when values of the second derivative are positive, then the original graph is concave up. And similarly, when the values of the second derivative are negative, then the original function has a graph that's concave down. So the upshot of this is the sign of the second derivative tells you about the concavity of the original function. Now there's one last thing that's worth pointing out in this simple example. This is a case where you have all four possible behaviors. You can have part of the graph that's increasing and concave down, decreasing and concave down, decreasing and concave up, and increasing and concave up. So you have all four possible combination of behaviors between monotonicity and concavity, and the bigger point is that monotonicity and concavity are independent properties. Just because you know the monotonicity doesn't tell you you know the concavity, and vice versa. They work independently of each other. All four combinations are possible, and indeed, if you just look at the graph of sine, you get all four behaviors on the interval from 0 to 2 pi.